Hi everyone, thank you so much for joining today's session. Uh, let's just wait for like probably another couple of minutes before we get started with the session, probably like for another minute or so. And yeah, then once we have a few more people joining in, we will start off with the session today. So anyway, until then, I hope all of you are doing well and I hope all of you are safe. And in today's session, we'll be dealing with the concepts of data pre-processing, uh, and we'll also be working with feature engineering and feature generation. So it's just that when it comes to data science, there are a few really interesting things. For example, it's really necessary for us to work with the data that we have, right? And sometimes the data that we have might not be in a format that we expect it to be in. So, we'll be dealing with how we can probably make it in the format that we want it to be in, and what exactly is feature engineering, how can we pre-process the data that we have, and yeah, I mean that's something that we'll be focusing on in today's session. So yeah, I mean I believe we can get started. So yeah, it's 6 o'clock as well, so perfect. So once again, welcome all of you, and I'm really glad that you've joined today's session. So before we start off, I just like to give you an idea about what predictive algorithms do. Okay, so the idea of doing any data science project or machine learning project or artificial intelligence project is that you come up with a proper model which can help you to make predictions in the future, right? So even when we do a data science project, right, the idea is for us to come up with patterns, to understand patterns, to probably derive some insights out of the data. And finally, we should be in a position to, put forward these insights in a meaningful manner so that we can probably assess these features or we can probably assess these patterns and things like that in the future. So that's basically the idea of, predictive modeling and all of that as well. So you understand patterns in such a way that you can start predicting these patterns in the future in case they occur. So while we focus on that, that kind of basically forms the crux of machine learning and AI, all of that, right? Because in very simple words, machine learning, what it does is that it understands patterns from data, and yeah, I mean, is it basically trains your model to actually perform a certain analysis, or to perform certain predictions, right? Depend based on the analysis that's been performed internally within the algorithm. So we'll be dealing with more about machine learning and all of that in the sessions to come. But yeah, I mean, the idea of predictive modeling is to make sure that you can predict things in the future itself. Now, one very interesting thing about algorithms, especially machine learning and deep learning algorithms, is that uh, they usually require, I mean, usually most of the algorithms require your inputs to be numerals. Okay. So sometimes what might happen is, let's say you have a text classification problem statement, right? So in this particular case, you might see that the data that you have is in textual format, right? Because obviously text classification. So ideally you want to either classify this text as a spam message or a non-spam message. Okay. So when you're doing that, what's going to happen is that you cannot really build a direct machine learning model over this text itself, because machine learning algorithms and any algorithm that is used for predictive modeling, in fact, does not deal with pure alphabets per se. Okay, the idea of using machine learning and deep learning and all of these things is to simplify your task, right? But then it's not, I mean, these algorithms are not really intelligent to directly extract things from text itself. So we need to make sure that we prepare the data in such a way, you know in such a way that the algorithm or the model understands it. So pure text is something that the computer or the algorithm won't understand. So instead, what we have to do is we'll have to look at prepping these features in a proper manner. Okay. So what do we mean by that? So when it comes to text itself, right? Sometimes what can be done is you can possibly encode the text in a particular format. right? So you have a very common encoding technique called one hot encoding, which can possibly be used for um, you know uh, converting your textual inputs to numerical inputs. That's one thing you could do. But then sometimes one hot encoding gets really difficult because if you have multiple classes or multiple categories of data, it just becomes very difficult to have so many one hot encodings, because you might essentially, so if you have, like, let's say you have two categories, yes and no. Okay, you have a row, you have a column. Okay, you have a column in your data set which has categorical variables. So categorical variables are nothing but variables, I mean, that a column which particularly has values that belong to a particular category, either yes or no. So it's like either one of these two, let's say. Okay, I mean, categories can be more than two as well. So you can have three, four, five, n different categories. Let's just consider this particular example for, where a column has just two, variables, categorical variables, yes and no. So in this case, since we have a yes and no, then ideally when we do something through one hot encoding, we'll basically have, like, since we have two groups, we will introduce two new columns. Okay, and these columns will basically be an encoding of the groups itself. So for example, probably yes might be represented as 00 and no might be represented as 11, or the other way around, something like that. Okay, so it's just a unique way to represent every category that's present in your data, in your particular column or the data set itself. Now, it was really simple when we just had two categorical variables, right? So yes and no, yeah, I mean, just introduce two more columns, and yeah, it's pretty simple. But this is where the issue arises. So assume you have a column with um, 20, 30, 40, 50 categories, 100 categories. Okay, then what's going to happen is that you'll have to introduce 100 new columns, right? And that gets very, very, very difficult. And I'm sorry, yeah, so it gets very difficult and confusing to I mean, it's very, very, very sorry about that. uh yeah, just give me a moment, guys. I'm facing some internet issues. Just give me a moment. By, if you can, please mention yes in the chat section. Right. If you can, please mention a yes. I'm sorry for that. I had a couple of internet issues, so just got I just made sure that they were fine right now. Seems okay to me. So if you guys can hear me, please mention a yes in the chat section. Perfect. Okay. So yeah. So getting back to the topic. So as I was saying, okay. So one hot encoding might work when you have a couple of categories, like let's say two, three, four, probably, or probably a few more. Okay. Let's say five, six, probably until 10. Let's even consider 50. But what if you have 100 different categories? What if you have 1,000 different categories? Okay. And I mean, these are possible, definitely, because I mean, it's yeah, I mean, a data set might have n number of rows. Sometimes you have millions of rows, and you might have 1,000 different categories within a particular column. So in that case, you would have to introduce 1,000 new columns again to encode each of these 1,000 categorical variables. So when such things happen, it gets really difficult, right? So I mean, you'll have to figure out a better way to probably come up with encoding your data. So we'll be looking at one such example today, okay, just to make things a little easier for us. So to get a clearer idea of things and understand how we can actually pre-process the data to make sense out of it. So for example, if you have textual data, how we can actually convert it into numerical in a numerical aspect. Okay, so that's one aspect we'll be dealing with. The second aspect that we'll be dealing with is we'll be looking at another project where we try to understand what the problem statement that we want to solve is, and accordingly generate features to make sure that we can achieve those goals. Okay, so that's another thing that we will be doing in today's session. But before that, there are a few points that I wanted to mention about feature engineering in general. Okay, so for this, we will have to get a basic understanding of how data sets usually look. Okay, so ideally, when we deal with data sets, you have a couple of columns, right? And you have a couple of rows. Okay, so sometimes what happens is that there might be a particular column where where a particular cell, like there's a particular row does not have a value with respect to a particular column. So for example, let me just show you what I'm trying to say. So I'll be sharing my screen with you people. Okay, so let me just take so okay, so let's just look at this particular data set. So this is something that we already went through in the first session itself, right? So we actually built a data set over the historic stock prices using the Quandl API. So we'll just look at that particular data set. Okay, so over here, if I mean, like, if you try understanding your particular data set, you will realize that you don't really have any NaN values. So NaN values are basically something where NaN values are values um, that refer to null, basically, in a simple sense. Okay, uh, so it basically means something like this. So for example, in this particular row, okay, so right now I have all the data. Okay, but then usually when you're dealing with data in the industry, there are very high chances that you don't have data with respect to a few cells. Okay, so for example, you might not have data here, you might not have data here, you might not have data here. Okay, you might not have this particular data. So all these data might be missing. Okay, so when such data is missing, you don't really have any effective data to make sense out of. Okay, and you can't directly pass your data set, which is this impure. So this data set over here does not have a few values here and there, right? So ideally, these cells where you don't have values, these cells would be called as Na. I mean, like, values in these particular cells would be represented as NaN. Okay, so NaN stands for not a number. And yeah, I mean, in such cases, it becomes really, you know, I mean, it becomes really interesting actually to deal with the data set itself, but you can't directly, pass this data set as an input, or, you can't pass this data set as, you can't pass the columns of these data sets as inputs to your predictive model. Okay, so before you pass it on, first you'll have to make sure that you have some values over here. You fill these cells with certain values. So usually people use central tendency measures like mean or modes or medians and all of that to fill the value of a particular column. uh, so you can, I mean, depending on the problem statement, depending on your data set, you will also have to figure out what is a more optimal thing to use. So sometimes people might also use a previous value itself. So for example, now in this particular cell I don't have a value, right? But then in the previous cell I have this particular value over here, so I might as well just take that particular value and put it out here if it makes sense. So would it make sense though? So over here this is basically total trade quantity, right? So before I even understand if it makes sense or not, so this, the value that's missing over here and here, is basically total trade quantity, right? So before I even figure out whether this particular thing makes sense, whether it makes sense for me to fill it with a mode, median, or average, or if it makes sense for me to fill it with the previous row's value itself. So before I do all of that, first what I'll have to do is I'll have to understand that particular column, right? So in this case, total trade quantity, how does it look? So it starts at one value, increases, then decreases, then I don't have a value over here. Okay, fine, no issues. Then again, there's this value, it increases, decreases, increases, increases, decreases. So you constantly have some pattern that's going on, right? And I mean, we can't really, and honestly, it wouldn't make sense for us to, probably use an average over here, mainly because, the average might not really give us enough data. So there might be certain days where the total trade quantity is extremely high. Like for example, um, in the future, sometime in the future, what might happen is the total trade quantity might be really high. So it won't make sense for us to incorporate all those very high values into a certain cell which might possibly have a low value, right? And also at the same time, I wouldn't really prefer taking a mode or a median as well, because if I do, then I mean I'll be taking the median value, and if I take the median value again, it might be closer to the value in that particular cell, but then I might lose the context of that row. Similarly, as in the case of using the mean, if I use a median, I might again lose a context, mainly because the value over here might not be close to what it is actually supposed to be, right? So I mean, it wouldn't really make sense to take a mean, mode, or median. So I think a safer bet for me over here would be to just take this value as it is and put it over here, because and probably just store the NaN cells for total trade quantity column with the values from a particular from the previous row. I mean, like, so for example, over here, since I have 6,99,623, I would probably fill this particular cell as well with the same value, because it might make more sense for me to do that. Over here, obviously, I mean, I'm probably not getting the entire context value, but I'm hopeful that I will be pretty close to what the actual value is supposed to be, because I mean, see, we do see fluctuations, but end of the day, these fluctuations are pretty minor, right? So it goes down by probably 10,000, or sometimes a lakh, or sometimes, yeah, it does go beyond a lakh. But yeah, I mean, let's just take that as a safe bet, and it's better to just take the previous value itself. So you always need to make sure that you deal with missing values in your data set, and a lot of times you will be missing values within your data set itself, and you'll have to figure out the best possible strategy for you to fill these missing cells with, what particular values you could fill these missing cells with. So for that, you'll obviously have to understand a particular column itself. So one of the first steps you need to do with respect to exploratory data analysis when you're actually dealing with a particular data set is to make sure that you understand which columns have NaN values. Okay. So once you do that, you'll be in a better position to figure out how you treat those missing values depending on the column. So how you treat every column's missing values will vary. Okay, it all depends on how that particular column acts or what that particular column corresponds to. Okay, so yeah, I mean, I would that's probably one of the first things you'll have to do, because this missing value imputation is actually one of the most important aspects. Because if you don't fill in if you don't fill in these missing cells with a particular value, then your machine learning algorithm is not even going to get trained. So you'll have to make sure that you fill these cells with some value or the other. But you need to again make sure that the value that you fill it with is somewhat close to what it could possibly be. Okay, so you will have to figure out the best possible strategy that would work for you in your case. So that's one aspect. Okay, so missing value imputation is one thing. So this comes under feature engineering, by the way. So feature engineering is a set of a lot of things. So the part where we discussed about one hot encoding, that is feature engineering. So basically dealing with textual data and trying to convert it into a numerical aspect, that is feature engineering. And filling in the missing cells with a certain set of values, again, that is also feature engineering. So there's this really interesting article that that we have. So let me just check where we have that. Yeah, so this is the one. So I'll be sharing this particular link with you people on the YouTube chat itself. So please do have a look at that. Probably not now, at some other time. Whenever you guys are free, you can just have a look at that. But then it talks a lot about how exactly feature engineering works, and what exactly feature engineering is all about. And just to go through a few things, so we already spoke about categorical features, one-hot encoding, missing values. Another very important thing is this thing called normalization. Okay, now what is normalization? So normalization is basically trying to scale your values in a particular column between two particular intervals. So let's say you have values ranging from 0 to 1 lakh, right? This particular interval is huge. Okay, and sometimes what might happen is that your machine learning algorithms might get a little, they might go a little haywire because of this huge range. Okay, so you want to make sure that you make the work easier for your machine learning algorithm itself, right? So for that reason, one thing that people usually do is they normalize their columns, or they normalize their data set. So normalization essentially, for example, when you have values from 0 to 1 lakh, let's say you want to scale down these 0 to 1 lakh values which range from 0 to 1 lakh to a scale of 0 to 1. Okay, that is possible, and that is what normalization helps you with. So here, since we're dealing with a smaller scale of values, you might be able to improve the sensitivity of your machine learning model or your predictive model, because it might be so it might be prone to change in a faster manner. So if you're looking at identifying even the smallest of changes, you might want to normalize the values to as small a scale as possible. And again, so it's on you, so you can decide how between what range and what range you want to normalize your values between. Usually we normalize the values between -1 and 1, or 0 to 1, because we do have a few we do have a few formulae for that. So when you're trying to scale normalize your values between -1 and 1 for a particular column within a data set, that is called standard normalization. And in case you are trying to scale the values between 0 and 1, we call it feature scaling. Okay. And apart from that, I mean, you have a lot of other things that you could focus on. We also spoke about, textual stuff. We'll also be looking into that in just a minute. So it's something that's really interesting. Okay, so we'll be getting to that. But yeah, I mean, feature engineering is one very important aspect which falls into exploratory data analysis itself. The whole part about exploratory data analysis is to understand your data set and make sure that you have enough features and meaningful features, and make sure that your data set is in the perfect format to actually be fed in for predictive analysis eventually. And obviously, apart from that, it's also about you understanding and building a relationship with the data, because if you don't build a relationship with the data yourself, you might not really be in the best of positions to make sure that you invoke a machine learning model to build that relationship for you. So if you really want to understand how exactly you could possibly build that relationship with data, first you need to do some exploratory data analysis, and this feature engineering part follows a very important aspect of that. Okay, so we'll be looking at one example. Okay, so this part of feature engineering, right? So let's just go back. So we'll be looking at this example wherein, so we had this really huge issue at Vidya in the beginning. So there were a couple of people who were building who were actually creating fake accounts on Vidya. So I mean, we didn't really have a robust sign up mechanism. So for example, if someone tried to sign up using some using an account like test at the rate gmail.com or abc at the rate gmail.com or 123 at the rate gmail.com, we would still actually create an account on their behalf, and that kind of started increasing our storage space. And at the same time, we weren't able to figure curb it out, and we want to make sure that the accounts on Vidya's portal were actually authentic accounts. So for that reason, what we decided to do is we decided to build a fake email classifier. Okay. So essentially, what that did was that we took an email ID as an input, and the output was basically to figure out whether that email ID was a fake one or a genuine one. Okay. So unfortunately, in this particular case, I will not be able to share the data sets with you. I won't be able to show you the data set because we actually work with some sensitive data. So I won't be able to show you the data set. But just to give you a glimpse of how the data set looks, the data set has about 6,000 true email IDs that we have from users of Vidya. So we use these email IDs to actually understand what genuine email IDs could actually look like. And also at the same time, we have we had a couple of fake accounts that people registered with. So we took those email IDs from the database, and we also generated similar fake accounts. Okay, so we built a very basic script to do that, a Python script to do that particular thing. So we generated a couple of fake accounts as well, and then we combined these genuine accounts with fake accounts, and then that formed our data set. um, so that's basically about the project. So we'll be taking out an email ID, and we'll be trying to predict whether that particular email ID is actually a genuine one or not. So in today's session, we will not be dealing with the prediction aspect. So we'll be only looking at how we deal with this textual data, because end of the day, email IDs are all text, right? So I mean, yes, you might have something like you know I am Ritik Roshan 123 at the rate gmail.com. So you do have numbers over there, but mostly, I mean, you get the point, right? So it's basically a string. It's basically a string, right? That your email ID is basically a string. So it's basically a set of characters. So you might have something like Rahul123 at the rate gmail.com, or XYZ123 at the rate gmail.com, or you might have pure text. You might have, probably you might have a few uh, other special characters like dot, underscore, hyphen, something like that. So yeah, I mean, the thing about this particular thing is that we can't directly feed all of this particular information into our predictive model when we build it, because as I mentioned earlier, predictive models require numerical values only. Okay, so these algorithms, these machine learning algorithms, they require to have only numerical data passed in as inputs. So we need to make sure that we first change this particular email IDs into numerals, right? So how can we change it to numerals? So one of the first things that might probably come to your head is probably encoding it in some form or the other, right? Great. So what encoding could we use? Could we use one hot encoding? So think about it. Email IDs are usually, very specific, right? So you can have only one. So in case one person has an email ID which goes like rahulkumaran313 at the rate gmail.com, then another person cannot create an email ID with the same tag, right? So he can't have Rahul Kumaran 313 again. He could probably have 314. Another person might have 315, 316, 317, 318, etc., etc., right? So going by that logic, ideally, when I'm dealing with 6,000 email IDs, I would probably have 6,000 different email IDs, all of them. So if I try to use one hot encoding in that case, I will have to introduce 6,000 different columns. And honestly, it won't make sense, because I mean, we'll be treating the entire column as a categorical column, whereas it's not really a categorical column, right? I mean, none of the values are ever going to repeat. None of the values in the column are ever going to repeat. So it doesn't make sense for us to go with one hot encoding approach. So what could we possibly do? So in the end, what we decided to do is we decided to, so we required numbers, right? And email IDs are end of the day characters, and every character has an ASCII code, right? So ASCII stands for American Standard Code for Information Interchange. So every character has an ASCII code. Okay, and ASCII code is usually a value between 0 to 255. So every character literally on your keyboard has an ASCII code. Okay, and the value would lie between 0 to would lie between 0 to 255. So so we thought, okay, fine, why not actually do that? So why not actually try to convert the characters in the email ID to an ASCII code, because ASCII codes are numbers. So first of all, that would actually help us pass the data into the predictive model that we're trying to build, and also at the same time, it would help us maintain the context information, right? So when I say if Rahul at the rate 123 is actually a genuine email ID, and if XYZ at the rate gmail.com is actually a fake email ID, then I need to preserve the context. I mean, I need to preserve the flow of how these characters are going on, right? So I need to preserve that flow. I need to preserve that context. And when I use ASCII values, so the interesting thing about ASCII values is that, so let's say I want to find the ASCII value of A. Okay, so the ASCII value of A is 97. Okay, so if I want to find the ASCII value of B, 98. If I want to find the ASCII value of C, it's 99. So over here, ideally, so in case I have an account like abc at the rate gmail.com, let's say, so I have an email ID of this sort. This is basically a fake ID. But now, when we're dealing with such data, one thing we need to ensure is that, first of all, when we're passing this as an input, we need to make sure that the input is in the form of numerals to make sure that get the machine learning model to function. At the same time, we also need to make sure that we, no matter how we are changing the data, like when we're changing data from textual manner to numerical manner, we need to make sure that we preserve the context information that could possibly be conveyed, right? So for that particular reason, this would be a great approach, because since we're taking numbers, so we know that abc at the rate gmail.com is obviously a fake email ID, right? So A comes before B and B comes before C. And similarly over here, 97, 98, 99, 97 comes before 98, 98 comes before 99. So we're preserving that order even over here, right? So that's something that we really need to ensure. So when you're trying to convert textual values to numerals, one, make sure that you preserve the contextual information that exists, because that contextual information provides a lot of information to your machine learning model. Okay, so it could possibly provide a lot of information to your machine learning model. So make sure that you always preserve that information. So no matter what approach you're using, even if you're using probably some other encoding method or something like that, make sure that you preserve the information in the right format. Okay. So yeah, so that's what we decided to do. So we decided to go ahead with the ASCII transformations, and I'll be showing you a code of how that's being done. So ideally, first what we did was we had a data set. Okay, so we first made sure that we shuffle the data set that we had after, because we didn't want all the genuine accounts to be in one place and the fake accounts to be in one place. So we jumbled the data set so that, we have a mix of different accounts. So yeah, so we first opened that particular shuffle data set, okay, in read mode. So ideally, this particular open function is basically a file operation function. So in case you want to read a particular data set or read a particular file, it could be any file, you could use this open function. If you want to read it, all you need to do is, so open function takes in two arguments. So one is the name of the file itself and the mode in which you want to open that particular file. So so the name of the file could be anything, okay? And this particular thing over here, you could have R, A, or W. So R stands for read, so you could open the file in read mode. A stands for append, so you could open the file in appending mode, or W, which means that you could open the file in write mode, okay? And sometimes you can have some other modes as well. So you could have R plus, you could have A plus, you could have W plus. So ideally that means that you're just appending, you're just having another aspect as well to your file. So over here, when we're saying open this particular file in W plus mode, so we're actually doing basically what we're doing is we're opening it in the write mode plus the read mode. That's what it means. Okay. So yeah, so we open the file over here, okay, in write mode plus a read mode, and over here we're just opening the file in read mode. Okay. Now, ideally, what we want to do is if you remember, we want to make sure that we convert the entire textual email address to a numerical format, right? So for that, what we're doing is we also need to clean the data. So we thought, since the at the rate and the dot might not really provide enough contextual information, we thought it doesn't really make sense to have. So for example, in an email ID like abc@gmail.com, so honestly, what really matters to me is probably the ABC and probably the Gmail and the com part, right? The text part. And probably I don't really, I mean, I think this particular dot and this particular at the rate sign don't really provide a lot of information. So this comes under a step called pre-processing, where we decided to replace the at the rate with nothing. Okay, so basically we don't replace that. So we just take the at the rate out of the string completely, and we replace it with nothing. And at the same time, we're also removing the dot from a particular string and replacing it with nothing. So that's something that we initially did for the pre-processing aspect. And also apart from that, over here, since we're dealing with data sets in the in files, so we're not so if you notice, we didn't read the CSV file using the pandas function. The reason we did that was because we wanted to make sure that we could you also append the outcomes of a particular email ID. So right now, when you say that an email ID is genuine, how do you know that it's genuine? You need to have some label that says that it's genuine, right? So for that particular case, we decided to open this particular file in, using normal file operations part, so that we can introduce the outcome itself into the particular data set. So that's what we did over here. And then finally, now I mean, like, we now here comes a critical aspect. So for every letter within the email ID, right? So we want to get the ASCII value. Okay. So in Python, you have this function called ORD, which gives you the ASCII value of a particular character. Okay. But for that, what we'll have to do is we'll have to go character by character, because at the end of the day, we also need the ASCII value for every character, and we can't have an ASCII value for the whole string, right? So we need the ASCII value for every character present in the email ID, and that's exactly what we're doing over here. So we just run a for loop. So we iterate through the entire email ID. So from the first character of the email ID to the last character of the email ID, we run this particular for loop. Okay, and then what we do is we convert the so we try to understand each and every we look at each and every letter within that particular email, and then we try to get the ASCII value of that particular letter, and then we store it in a dummy list called letters, so that we can add it to our data set eventually. So yeah, so we basically do that. Now we also need to make sure that we create a data set out of it, right? That is why we open this particular set in write mode, this particular file in write mode. So for that reason, what we do is we use a delimiter as comma, because we want to store it as a CSV file. So we use a delimiter as comma, and then we join the letters using the delimiter comma. Okay, and we just make sure that we add all the values over there. So over here, one assumption we've made is that so now an email ID, your username part basically. So a username is nothing but all the characters which come before the at symbol in an email address, right? So for example, if I have an email ID like, Philip James 123@gmail.com. So this Philip James is something that forms the username of that particular email ID. Okay. Now we have assumed that the longest possible the most number of characters that can be present within an email ID is 40. Okay, so in case if it's less than 40, I mean we will have a few empty columns, right? So what we decided to do in that case is that we decided to fill these empty columns with zeros, because ideally what we're saying is that these zeros mean nothing. Okay, so we are filling it with a zero value so that it doesn't really add a lot of context or any extra context to our particular thing. So basically, whenever we encounter our first zero, we could say that there comes the end of the email ID. Okay, but then the thing is that you cannot have different number of in every row you need to have you need to make sure that every row of every column has or has is completely filled. Okay, so if you remember in this particular data set where we saw, I told you that we'll have to fill up all the missing values, right? That is because if you don't fill up the missing values, then you're going to get an error because you don't have all the values filled. So you need to make sure that every cell is filled with some value or the other, and that's exactly what we're doing over here. So since we have defined 40 to be the highest length, or the 40, so we're saying that a username can be of max 40 characters. So and since we're saying that, we need to make sure that in case if it's less than 40 characters, we still fill these columns for that particular row with certain values, and the value over here that we're filling it with is zero. So we need to make sure that we take care of that as well, right? So all of these things basically come under pre-processing and feature engineering. Okay, so it's a beautiful thing, because when you look at problem statements like these, ideally you're going to be looking at, more than looking at what algorithm to use for the prediction part, you should be looking at how exactly you can frame your data set. Okay, because end of the day, all the algorithms that you use are just going to be as good as the data set that you have. So you need to make sure that you have the right data set, and make sure that the data set is being uh, engineered in the right manner, and also at the same time make sure that you pre-process your data set to have all possible, I mean, to ensure that every column of every row has a value within. So basically every cell within your data set has a value. Okay, so the pre-processing aspect, I mean, apart from just ensuring that no NaN values exist, it also helps you to come up with such strategies, right? So I mean, this is a pretty good strategy. Otherwise, how would have we come up? How would have we classified the email ID as a fake or a genuine email ID, right? Because we can't directly send textual data, so you need to process your data sometimes. So it's always nice to work with textual data, especially because there's a lot of processing involved. So whenever you're working with images, audio files, textual data, um, things like these, you need to make sure that your data is processed in the right format, because again, every machine learning and deep learning algorithm takes only numbers. Okay, so since it takes only numbers as inputs, you need to make sure that these images, these audio files, these text, all of these are converted to numerals or numerical values. How you do it is what comes under pre-processing. Okay, so you have a lot of strategies, and all of these strategies can only be explored all of these strategies can only be explored if you actually go through go through a few articles, probably work on a few projects, because and few different projects. So that's something that you'll be able to explore only if you get some hands-on learning and work on your own set of problem statements. So yeah, I mean, over here we've just given you one particular aspect, one particular approach that could be followed. Okay, so this was basically about the pre-processing and feature engineering part. Okay, so this was one aspect that we wanted to deal with today. The other aspect that we wanted to deal with was feature generation, right? So so honestly, today's session is going to be a fairly short session, because we won't be dealing with the predictive aspects today, right? So today's session is more about just the pre-processing aspect, the feature engineering, and the feature generation part. So we'll just be dealing with these parts. We're not really going to be focusing on how exactly we could create a predictive model or a machine learning model, right? So that's not the purpose of today's session. So we'll be dealing with that in the coming session. So since we have 2 sessions left, we'll be dealing with quantitative modeling in one of the sessions, and in the next session, finally in the last session, basically, you'll be dealing with deep learning models and machine learning models. So we'll just be going through it, just have a rundown through those algorithms. But today's session is going to be purely about the pre-processing part and all of that. So since we're done with one part, let's move on to the next part, which is feature generation. Okay, so this particular project is related to the data set that we created using the API Quandle in the first session, right? So we had, so we basically created a data set with historical stock prices, right? So we had like 50 stocks from the Nifty 50, which we used to actually get, the data for all of these stocks from the very beginning of their movement in the National Stock Exchange. So we're using these data sets to ideally, build a model. But what is the project? What is the aim of this particular project, right? So the aim of this particular project is to work on something called information asymmetry. So let me just show you. Yeah. So basically the aim of this particular project is to quantify information asymmetry and explain something called the EMH, or the efficient market hypothesis, better for accounting for the information asymmetry. So let me just make this simpler. Okay, so too many terms over here, right? So first of all, this project belongs to the fintech domain. So fintech stands for financial technologies, and it's one of the most booming domains out there. Okay, so I'm pretty sure a lot of you must have heard about this term stock market a lot of times, right? But what exactly is the stock market? The reason why it actually is so much fun is because, and, so interesting to look at, is because you see the prices constantly fluctuating, right? So these prices probably fluctuate because of a lot of reasons. It might be because of the performance of the company, the perception of that particular company in the community, or in the market outside, and you try to understand, and all of these factors kind of promote how the stock price goes. Because if a lot of people are selling a particular stock, then the stock price is going to come down, because it kind of shows that probably people don't have a lot of confidence on that particular stock. At the same time, if the cost of a particular stock is constantly going high, then ideally it would mean that people have a lot of confidence in that particular stock. Okay, but now the reason, if you notice, if everyone had access to the same information, right? So if everyone bought the stock at the same time or sold the stock at the same time, there would not be a lot of fluctuation in the stock market, thus making it probably less interesting, right? So in stock market, there's this very important concept called information asymmetry, which basically states that the information that is possessed by everyone within the stock market is not the same. So asymmetry itself kind of says that there is some knowledge gap between people who are buying and selling, right? So some people might actually think that a particular stock is actually going to do well, and they might end up buying that stock. And at the same time, there might be certain people who think that the stock is not going to do well, and they might end up selling that stock. And that is because people have access to different information, different sources, and all of that, and that is what constitutes information asymmetry. So different people having access to different information and not the same information is called information asymmetry. So ideally in this project, we are trying to come up with a way to quantify that information asymmetry, because right now, until now, there has not been a way where you can quantify information asymmetry. So you can probably say that, okay, fine, there are people who don't have access to information, or this particular market has majority of the people who have access to all the information and all of that. And then you can probably classify these markets, but then you don't have a way to quantify information asymmetry, and that's what we are trying to do in this project. Okay, so the reason why we're doing this is because we want to explain the efficient market hypothesis. So efficient market hypothesis essentially states that all the information available about a particular stock will reflect in the stock price. Okay, it's as simple as that. So all the information available to the public out there will all be included within the stock price, because that is what kind of promotes people to buy or sell a particular stock, right? So basically EMH, what we're trying to do is we're trying to quantify that information asymmetry and explain the efficient market hypothesis in a better manner for that quantification of information asymmetry. Okay, might sound a little too vague, might sound a little above your head, or probably it might be going over your head. No issues with that. Don't worry much about that. Just focus on the concepts that we're trying to explain. If you understand what the idea of the project is, it's amazing, because you might as well want to work on it during your free time, or just explore it, because it's an amazing topic to work on. But yeah, I mean, it's fine if you don't understand the idea of the project, because anyway, we'll be going through the code, right? And I'll be explaining what is required from the data science perspective. So don't worry much about that. Okay. So just give me a moment, guys. Let me have some water. I feel a little dry in the throat. Okay, perfect. So getting back to the project. So yeah, let's go back over here. So the purpose of looking at this particular project is to look at something called feature generation, right? A lot of times what happens is that the data set you have might have just a few columns, right? So over here in this particular stock price data set that we have a date, we have a column called open, we have a column called high, we have a column called low, last, close, total trade quantity, and turnover in lakhs. So we have about 1, 2, 3, 4, 5, 6, 7, 8 columns. Okay. But then are these 8 columns sufficient to do what we want to do? That's always going to be a question, right? Because um, sometimes it might be sufficient, sometimes it might not be sufficient. It depends on the problem statement you're trying to solve. And over here in this particular problem statement that we're trying to solve, it was definitely not sufficient. Okay, because we need to make sure that we took into consideration a lot of other factors as well. So one primary aspect over here with respect to computing information asymmetry and performing, trying to quantify that, is something called technical analysis of stocks. Okay, so technical analysis of stocks kind of tells us towards what direction the stock was moving on a particular day, depending on a lot of factors like the money flow, or the I'm sorry, the money flow index, or things like um, the rate of change and all of that. Okay, so how often it's prone to change, how much money is flowing into it, and the central commodity index and things like that. So you have various terms in stock markets. Honestly, not everyone understands these terms, and even I personally don't understand all of these terms. But there are a few things that that pertain to doing a particular technical analysis for a stock, and that's something that is really essential for this particular thing. So obviously this particular data set that we have is not sufficient to perform or build a predictive model and quantify the information asymmetry. But what could we do about this, right? This is all that we have, and we need to work with this right now. Okay. So what we could do is, a lot of times with the data that you have itself, you can actually generate more features. Okay, and that is the beauty about the data sets that you actually get, because every time you have a data set, you should be looking at what features you could possibly generate. Okay, and all of these technical analysis metrics like the money flow index, RSI, ROC, CCI, all of these technical analysis indices can be computed using the data that we have. Okay, so that's the best part. So using the data that we have, we can actually compute the technical analysis measures. Okay, so all these things, these functions that you see, we've taken it off from the internet. Okay, and we're also using a module called TA, which stands for technical analysis. So using the technical analysis module to actually perform all of these, perform the technical analysis aspect. And finally, we're just combining all of them together over here. But if you notice, as I mentioned, we can generate more features, right? So over here, all we do have a data set to read, but then that's something that we're doing over here itself. So if you notice, we're defining a class called technical analysis, and then we have a constructor which takes the data frame as an argument. Okay, and it assigns that to this particular self.data. So all these are class instances. Okay, so we're just defining this within the constructor so that we can use it at a later point in time. So this ROC, CCI, money flow index, RSI, you don't really need to worry about these things. These are basically just technical analysis measures for performing a technical analysis on a stock, on a particular stock's history. Okay. Now, as I mentioned, it's all about feature generation, right? So all of these things can actually be added as features to a particular data set itself. So what we're doing is so after doing some analysis, we realize that the ROC and CCI are not really corresponding to a lot. They're not giving a lot of information. So we decided not to include those within the data set, although we've generated the data for that. So instead, what we decided to do is we just decided to add MFI and RSI into the data set. So how can you add a particular column to a data set, right? It's very simple. All you need to do is you need to call that particular data frame and reference it. So just, within square brackets, mention a particular column name. So in case that particular column already does not exist, it'll create a new column for you. Okay. And over here, if you notice, so the return type for all of these values is basically a list, okay, or you could call it a panda series, okay. So panda series is similar to that of a list, but yeah, I mean, ideally what it does is it kind of just pushes it out for you. So it just gives you the appropriate return type. And over here, when you're actually assigning a particular column with certain values, the value that you need to assign to it should be of a type of list or a data frame or a series, a panda series. So just remember that, keep that behind your head. So over here we have generated a few technical analysis measures, which is great. So we've got a couple of new features over here, which is amazing. But what else actually influences the stock price part, right? Now, just think about it, okay? So if now a particular stock actually is there in the stock market, and what really matters is how it's performed in the past, right? So you need so financial data forms something called comes under the category of time series analysis. Okay, so time series analysis is nothing but data which is data which is dependent based on the time. Okay, so based on the time you might see various changes, and this particular time based changes provide a lot of contextual information. Okay, and these contextual information are really important to capture, right? So here, if you notice, we have we have daily data, right? But then are we, I mean, like in a particular row we don't have any context, right? So we don't have context about what the previous day's closing price was, or we don't have the information about what the closing price of that particular stock before 2 days was. But we do have all that information over here itself, right, within this column. If you notice, if I look at this particular day over here, 21st, if I want to see what was the closing price of the stock on the on like 2 working days before, I can clearly say that it was 581, or that might I think that's the high price. My bad. So let's say 613.9 is the high price on 21st of um, 08 is August. Yes, so 21st of August 2007, the high price on that particular day was 613.9. But if I want to understand or provide a context of what was the high price 2 working days before, then I'll have to go 2 rows above to check that out, right? But honestly, I don't have that context information in this particular day itself, so I'll have to go column wise. But I would rather prefer having it in a row wise manner. What that essentially means is that I would rather prefer having that as a feature, right? Because a particular stock, the performance of it in the future depends on how it has done in the past, right? So if you see a particular stock going up, going up, going up, there are high chances that it might actually keep going up even even on the next day, right? So if a particular stock has been performing excellently for the past, let's say, 10 years, very high probability that it will perform well again tomorrow, again day after tomorrow, and the days after that as well. So you need to have some context information over there, which is not present over here in for a particular day. But I do have that context information present in the column itself, which I can incorporate. So that is something that we decided to do as well. So we decided to add the past 21 days closing prices. Okay, so for that, what we did was similar to what we did over here. So ideally, we just got the closing prices of so for the first 21 days, or for the first 20 days, we made sure that we assigned the values 0, okay, for the previous 21 days context, because ideally you don't have 21 days before the first 21 days itself, right? So only from the 21st day or like 22nd day onwards, we could actually see some see the past 21 days history, right? So until we reach that point, we made sure that we just gave, the values of 0, 0, 0. So we basically introduced 21 new columns over here, and each column corresponded to the closing price of a particular day, like particular previous day. So for example, a column called C1 was created, okay, and this column C1 was nothing but the closing price of the stock one day before, okay. And then there was a column called C2 which was created, and this particular column C2 consisted of prices which a closing price 2 working days before. Similarly for all the days, and basically C21 was nothing but closing price of that particular stock 21 days before. Okay, so let's just go through the entire code anyway, just to give you a better sense of things. So we already have the data set, right? So it's basically stored in the self.data. If you remember, in the constructor function, we initialize the class with a data frame, right? So you'll see where the class is being initialized. It's basically being initialized down here, okay? So we're initializing it down here, and we're reading the CSV file over here. We're passing that data frame over here. Now going back to this particular thing. So yeah, so basically we're referencing that particular close column because that is what we are going to be dealing with right now, and that is what matters to us at this particular moment, right? Because we want to add the closing price for the past 21 days. So obviously we will have to go to the close column. So we call the close column and convert it to a list. This is just for the sake of convenience. That's pretty much about it. The reason we're converting it to a list. And then I'm defining 21 empty lists. Okay. The reason I'm doing this is because I want to be able to store the values of, store the values, right? So for every column, what's going to happen is that, for every row, I'm going to be storing 21, the past 21 days data. And then similarly, I'll have to store it for multiple days, right? So to ensure that I can do that, I'm introducing lists, because end of the day, I can store this particular, so in case I find the closing price for, so I come to data for today. I want to find the closing price one day before. I store that in the C1 list. I want to, again, I want to find the closing price 2 days before today. I find that out and I store it in the C2 list. Similarly, I store, the closing price 3 days before today in the C3 list, so on until C21. Now, again, when I go to tomorrow, right? So when I go to tomorrow, the closing price for, the 1 working day before would be today's closing price, right? So I'll have to store that again in the C1 list. And then closing price of 2 days before tomorrow, basically, let's assume we are at tomorrow already. Okay. So closing price 1 day before would basically be today's closing price. Closing price 2 working days before tomorrow would be the 2 working days prior's price, which will be stored in C2. So similarly, I'm just maintaining column wise data and day wise data, which helps me just directly append this particular column to the data set itself. Okay. So for that, what I'm doing is so to actually understand the closing prices, what I'm doing is I'm running a for loop for the entire length of this particular closes list, right? And what I'm doing is I'm just checking if it has 21, if it has 21 days. So I'm doing this particular statement in the very beginning, because what might happen is that ideally, as I mentioned in the beginning, I want to store the past 21 days context information. Okay. And in case I don't have 21 days context information, I just want to store the whole 20, the whole 21 columns for that particular row with zeros. Okay. The reason I'm doing this in the very beginning is because if I don't have 21 columns, let me directly just store zeros, right? So it would just make more sense rather than computing, all these things and then finding out that, you don't have 21 days of data. It wouldn't make sense, right? So it's just wasting computational power. So I just put the statement in the very beginning to ensure that we don't do a lot of computations and we figure out whether we have 21 days of data present or not. So ideally, if, so let's assume, okay, so let me just show you. So if I say A is equal to 1, 2, 3, 4, 5, okay. Now let's say that, I want the past 2 days closing prices. Okay. So ideally, what that would mean is that when I come to, so for this particular day, I don't have two past closing prices, right? For this particular day, I have one closing price, but I don't have another closing price, like, another past closing price. But from third onwards, I have two closing prices every day, right? So, like, I have two past closings. So again, on fourth, I have two past closings. On fifth, again, I have two past closings. Now, the thing is, now basically what I want to do is I want to check if there are two, past closings, right? So this particular thing is my first element. So first element is indexed as 0, right? So basically what we're trying to do is trying to, uh, check whether we have, that enough information present. Okay. And we're going to be iterating through a loop. Okay. So now, for example, if I want, let's say, the past 21 days, or past 6 days information over here, right? So if I want the past 6 days information, ideally what I'd have to do is, or let's take past 7 days information. Okay. So just to give you a brief context, when I say a of 0, I get 1. When I say a of 1, I get 2. So it's just that, the 0, 1, 2, 3, 4, and all of those things are going to be indices for your particular list. But now, when I try to check whether I have, something, so when I say a of minus 1, it gives me the last element. Okay. Then when I say a of minus 2, it gives me the second last element. Okay. But now the thing is that, let's assume I'm over here. Okay. And I want to check whether I have two elements before that, right? How I could possibly do it is by taking this particular value. Okay. And then checking if that I minus that particular value exists or not. So for example, over here, um, when I say, okay, so I want, let's say, 7 days of past information. So my I over here is 0. Okay. Now when I say I want my A of minus 7, so because I'm saying that, let's say that we have, on the first particular day, from here onwards, we're looking for the past 7 days context information. Okay. So if I have that, great. But if I don't, then what happens? So I get something like an index error. Okay. So now similarly, let's say so if I said a of minus 6, it's still out of range. So a of minus 5, now I get a value called 1. So basically, this is just a way for us to, figure out whether past closing prices exist or not. Okay. So that's the reason why we're using these try except blocks over here. So that's basically for error handling. Okay. So what we're doing is, first we're checking whether the past 21 days closing price exists or not. If it gives me an error, I'm directly going to the except block. Okay. And I'm just feeding all the 21 columns of that particular row with 0 values. And if it does succeed, then this is what I do. So I just go, like, 21 days before, 1 day before, 2 days before, 3 days before, 4 days before, and, just start storing those respective closing prices within the respective lists. Okay. So now I have the values over here. Great. But now I still have to, make these values a part of the data set, right? So for that, similar to what we did with MFI RSI, we do the same thing over here. So we just define new columns over here. Okay. And accordingly, we, just assign the respective lists associated with those particular columns. So ideally, with respect to the C1 column, I'm, putting up the small C1 list. To the C2 column, I'm putting the C2 list. And similarly, finally, for the C21 column, I'm putting out the C21 list. So now I've created like 21 new columns already, right? So if you've noticed, right? So the idea of this particular experiment was to understand feature generation, how we could possibly generate features. So one thing about generating features is that you will be able to generate features only if you have some domain knowledge about a particular domain. Okay. So if you don't really have enough domain knowledge, it would be very difficult for you to generate these features. So whenever you're looking at generating new features, make sure that you have some understanding of the particular domain, because to generate features with the existing data that you have would be a task, and you need to understand what sort of features you could possibly generate, which would be meaningful for the particular data set, right? So yeah, I mean, over here, since we had some domain knowledge, we were able to understand that the past prices, the past closing prices would obviously have some context information hidden within it. And we're taking the 21-day range because we just want to take it in the near past. Okay, we don't want to. So obviously, a stock price that, let's say, a stock is working today, right? The effect that the past 1 week might have on the stock might be more than what the effect of the stock prices from the very beginning might be there, right? Because the stock has evolved over time. It has taken into consideration a lot of factors, a lot of environmental factors, like how the people are responding to the particular stock, and it's come over a very long time, right? So the particular stock price depends much more on the recent past rather than the farther past. Okay, so this is something that we'll again be discussing once we deal with the predictive modeling part. But yeah, I mean, it's just an interesting concept when we come over there, and we'll be seeing how it is interesting and all of that once we reach at that particular point, which is on the fifth session. But yeah, I mean, we're taking the 21 days context because we just want to deal with the recent past and not the farther past, because we know that within stock prices, I mean, stock prices are more affected by the recent context rather than the farther context. Okay. So we've added 21 features plus two features over here, MFI and RSI. Now we want to add another feature, which is called returns. Okay. Now, what is this returns feature, right? So ideally, now if so now we have the closing prices for 21 days, right? So now what we want to do is we want to understand whether this particular closing price uh, actually has some effect on the returns aspect. Okay, because end of the day, we people are into stock markets because they want to generate a higher profit, right? They want to generate more money, they want to generate more wealth. So they're into the stock market because it kind of fluctuates so much that you can actually make a profit or a loss pretty quickly. So that's the purpose of the stock market, right? I mean, generating revenue, generating funds, building the economy, all of that. But now returns are one reason why people are there in the stock market for. Returns basically profits or losses, right? Ideally, people want profits. But now let's assume that, okay, so as I mentioned already, so if a stock has been doing well for, like, let's say, the past 1-2 years, highly likely that the stock will also perform well tomorrow. The stock will perform well day after tomorrow as well. So now we have taken, so in the previous step, we took the individual closing prices, right? But then now we want to add more context information. And what context information is that? So we want to see whether the stock price is giving a profit or a loss between two particular closing prices. Okay. So if the close price on one day is, let's say, 450, and the close price on the next day is 460. So ideally, in one day, this person has made a profit of 10 rupees per stock, right? And now let's assume that the stock price is 460 today, and tomorrow it becomes 449. Okay, so ideally this person has incurred a 11 rupee loss from today to tomorrow, ideally, right? But his net profit or loss is basically a loss of 1 rupee because he started with 450 rupees and currently the stock is at 449. So rather than focusing on the net, we are more concerned about the past 21 days context. Okay, so how is the returns fluctuating over the past 21 days? So that also obviously talks a lot about the buying and selling decisions, because if a stock is constantly at the higher level, right? If it's if it's making a profit all the time, right? If it's returning a profit, if the closing price is constantly going high, it means more and more people are buying that particular stock, but not many people are selling it, which kind of talks about probably various other factors which could influence that. But it gives us some information about the general perception about the particular stock. So we decide to also calculate the returns, and how we calculate the returns is very simple. We just take the previous so in case we want to calculate the return over here between C1 and C2, we just do C2 minus C1. If you want to calculate the returns between C2 and C3, we just do C3 minus C2. So it's a simple subtraction that we do, and we do it throughout the whole for all the 21 days. Okay, for all the 21 days we do that. So that way we have enough stock data, so enough return data. And yeah, so we just do, if you notice over here, these this is what I was talking about. So we subtract, so in case we want the returns on day C2, we just do, so in case we want the returns on day C1, we do C2 minus C1. In case we want returns on day C2, we do C3 minus C2. Returns on C3 is nothing but C4 minus C3. Similarly, and so on until the 21st day. Okay. And then what we do is, over here, we are looking at the average positive return or the average negative return. Okay. So we're constantly we are also keeping a track of, within these 21 days, how many times has the stock gone, in the positive side, and how many times have the returns been on the negative side. So we're keeping a track of that. And finally, what we're doing is we are appending those positive and negative returns as features into our data set. Okay, so over here, ideally, we are focusing on the positive and negative returns, and we're not focusing on the, net returns. Okay, so we're focusing on the average positive or negative returns over the past 21 days for a particular stock. So this way, what happens is we just get a lot of context about the buying and selling decisions as well, because we know that, for a matter of fact, that a stock price fluctuates because of the buying and selling decisions that people make. Okay, and since this thing is about information asymmetry, right, so since we're dealing with information asymmetry, we need to also take this into consideration, the buying and selling decisions, because that's what fluctuates the price of the stock, and that's what talks about information being asymmetric, right? So that's what we're focusing on. So here itself, again, we've added like 2 more new features, right? So we added 2 features here, 21 features here, and another 2 features over here. So ideally, if you notice, we've added 25 new features just with about 8 features that we had, literally. And honestly, like speaking about it, it's pretty much just been this one column that we've used to generate all our other features, right? So although we've had like a data set of 8 columns, we've kind of narrowed down on one column that helped us generate 25 new features, right? So ideally, now the data set has 25 plus 8 of these features, which is 33 features. And just look at it. I mean, we actually generated features from nothing, right? So like we were at 8 features, and thinking about, how we could generate features, we actually worked on it, thought about what could possibly be the, things that influence the stock market, what columns could possibly be used here, and using, one or two, a few of those columns, we've generated more such features, right? That is the beauty about feature generation. The reason why we generate features sometimes is because the features that you have over here might be good enough for the model, but then sometimes having more features helps you build a more better predictive model. Okay, and it just helps you take into consideration a lot of other factors. Like for example, we wanted to ensure that we included the past context, the past 21 days context, the past 21 days return history, and all of that, because we thought it gives us more sense to have that information present within as features into the predictive model that we would be building in the future. So that's the reason why feature generation actually helps, because it helps you build a lot of meaningful features to make a more meaningful predictive model. So that's pretty much about the feature generation aspect as well. I just wanted to give you a brief understanding of how you could generate features and what is the thought process that goes into it. So if you notice, this entire workshop, I've been taking people through various projects, right? So I've been taking you through various projects because I want to give you people an understanding of, what is the thought process, okay? Because data science, more than the skills involved, it's about the thought process that you actually follow, or the flow of thoughts that you follow. You need to understand how things actually go ahead in data science. That is why, more than focusing on just the code, we are focusing on the thought process, and that's why we're focusing more on the pipeline itself, right? So that's why we're going in a step-by-step manner with the pipeline. So we started with data collection, went to exploratory data analysis. Today we saw, data pre-processing, feature generation, feature engineering, and then in tomorrow's in the next session, day after tomorrow, we'll be also looking at the quantitative modeling aspect, and finally we'll be looking at the predictive modeling aspect. So it's like, a whole pipeline. It's a series of things, and we need to follow the series as it is. Okay. And it's really interesting as well, because the whole idea of data science, as I already mentioned, more than just the coding part, it's more about your thought process. It's about how you think about the particular problem. Okay. So when you think about the particular problem in a really interesting manner, in a different way as compared to others, you might get much different results. So it's really important that you follow a particular thought process, and that was the aim of taking you people through projects. Because data science, a lot of people out there, they might help you, like, understand. I mean, trust me, you go out there, you're going to find a lot of free courses where people say that, we'll teach you Python for data science, where we'll teach you R for data science. But then over here, we're trying to help you understand the thought process involved, because that is what forms a data scientist, and that's what sets a data scientist apart, right? I mean, obviously, apart from the domain knowledge as well. So, I mean, yeah, that's the reason why we're going through various projects and helping you understand the pipeline on the whole. So that's pretty much it for today's session. So I just wanted to deal with the feature generation part, the feature engineering part essentially, and the data pre-processing part. So that's pretty much it from my end about today's session. And in case you people have any further questions, I'd be more than happy to answer them for you. So I see that Vinay says he'll rewatch the session and he would like to try it out himself. Sure, Vinay, you should do that, because that'll really give you a lot of insight and intuition on how these things actually work out. When we share the code with you, I will also be sharing, one particular data set. So, it'll be easier for you to actually work it out. Yeah, so I'll be coming to that. But in case, people have any questions, I'd be, more than happy to answer them first before coming to the task. So I see Sachin has a question here. While creating a file using Python, where will it be stored? So Sachin, it'll be stored where you ask it to be stored. So for example, over here, let me just show you. Just give me a moment. Let me just share my screen. Yeah, okay, my bad. Sorry about that. Yeah, so over here, when I open this file, right? So when I open a file in write mode, in case this particular file does not exist, it will create a new file with this name. So, okay, it'll just be, so if you notice, if I remove this particular, sorry. So if this emails underscore dataset.csv file did not exist, then what would ideally happen is that when I open a file in write mode, it would create that file first and then start writing into it. So over here, this thing over here you see is basically the path where you want the file to be stored. So if I say something like, let's say, what could we say? Okay, let's say history/email dataset.csv, and let's just create, a folder called history. Okay. Now let me just run this particular function. Okay, so say what is that? Pre-process data. And so remember, I don't have any file stored within the history folder, right? So if you notice, this basically shows an extended version of the file, like the folder, and there's literally nothing in this history folder. Okay. So now let's run the preprocessing.py file. Okay. Give me a moment. Okay. So now if you notice, there is this email underscore dataset.csv file over here. So ideally what happens is that the path that you give here is the place where the file will be stored. So I hope that answers your question, Sachin. Sachin, if it did answer your question, please let me know in the chat section. Perfect, great. Okay, cool. So, okay, any other questions, anyone? So in case you have no further questions, please let me know in the chat section with a no so that I can, go ahead with what the task is. Please let me know in the chat section if you have no further questions. Okay, so since I'm not okay, perfect, Sachin. Cool then, cool. So what I'm going to do now is I'm going to be telling you people about what the task for today is. Okay, perfect, Zaw. Glad to hear that you have no questions either. Okay, cool. So the task for today, which you'll have to submit by 6 p.m. tomorrow, is going to be related to the you know the emails data set that we had. Okay, so what I'd like you to do is, so you have a couple of open data sets online, okay, where they have a few email IDs present over there. So I would like you to take one such data set which has real email IDs, or you could also create your own data set with a real set of email IDs, and at the same time also generate few dummy email IDs. Okay, and ideally, the over here, after you do this, I want you to make sure that you come up with a strategy for pre-processing. Apart from the way we pre-process the data right now, where we use the Ascii values, I want you to come up probably with another, preferably with another aspect of pre-processing. Okay, so after you come up with another, if you do actually come up with another aspect of pre-processing, or another aspect of generating these features and making these turn into numbers while ensuring that the context information is preserved, if you come up with a different method or different methodology, I would like you to write about it as to why you came up with that particular approach and why do you think it's better than the existing one. Okay, so that's basically your task for today. So it's about just taking out a few existing data sets. I mean, like proper data sets that we have, proper email IDs that we have, genuine email IDs. Take, or to be honest, you can actually just take about two or three as well. To probably just two or three of the email IDs that you probably know. Just take two, three email IDs of some order like that. Then you can take about two to three email IDs which you can just randomly generate. Like you can just say abc@test.com or abc@gmail.com. These are all fake IDs, right? Fake email IDs. Have a list of 6 such email IDs probably, just to make things simpler for you. So 3 genuine email IDs, 3 fake email IDs. And after you do that, make sure that you come up with a better pre-processing strategy. If you think there is a better pre-processing strategy, think about it. If you think there is a better pre-processing strategy, come up with one, code it, and also tell us why you think that's a better pre-processing strategy. Okay, and if you think the existing strategy that we just explained about with respect to in the session, if you think that itself is the best strategy available, again, explain why. Explain how you can say that that is the best strategy available. Explain probably the other approaches that you must have thought of, and just let us know why you think that's the best possible strategy available. Okay, so no matter which strategy you're taking up, you need to mention why and probably draw a comparison with the other approaches that you've looked up or thought of, apart from coding the approach itself if it's a new strategy. So this is basically the task for today's session, which you'll have to complete by 6 p.m. tomorrow. And yeah, that's pretty much the task. So any questions on that? Sure, Vinay, I'll do that. I believe you must have sent a message on Slack, so I'll have a look at that and I'll get back to you. So anything else, people? Sachin, ideally, we have actually sent the feedbacks to a couple of people. We do have a few in the few feedbacks that we have to give in the backlog. So in case you haven't got a feedback until now, you will be receiving it by tomorrow morning at the latest. So the thing is, we still haven't evaluated everyone's first and second tasks, because we got like quite a few of them, and we need to go through each and every code, right? So I personally go through each and every code, so it just takes a little time. So in case you haven't received a feedback until now, don't worry, you will be receiving one by tomorrow for all the tasks that you completed. Okay, cool. So any other questions, people? uh, you're welcome, Sachin, you're welcome. Cool then. So I believe you people have no further questions. So anyway, thank you so much for joining the session today. I'm pretty sure today's session must have been a little, I could say, hectic, because you had to learn a couple of new concepts, and it was a little intensive, honestly. So it's fine though, because once you start doing things, you'll start getting a better hang of it. So don't worry much about that. And it all depends on your domain knowledge as well. So whatever domain you're interested in, make sure that you have some knowledge about that particular domain. And that's pretty much it from my end, people. Thank you so much for joining the session today, and I'll see you people on Tuesday. Perfect then. Thank you. Thank you so much. Have a good day or have a good night, and I'll see you soon. Bye.